Hello everyone. You're watching my YouTube channel Chemistry by Saad. My name is Saad and today I am going to discuss a challenging past paper question. This question I got from OCR A-level chemistry and the topic is buffer solution and neutralization and how to make a titration curve, how to find pH. So this question is a challenging and harder question of this particular topic. Let's see how can I make this question easy for you guys. Okay. So guys, I have to make a pH titration curve. For this, I need to find pH. And in the question, you guys can see 20 cubic centimeter, which means 0.02 cubic decimeter. Methanoic acid having this Ka of concentration, this is titrated against a sodium hydroxide of concentration. This calculate the pH of the solution initially. So let's see how can I solve it. In part one, I have to find pH. I do not have given any volume of alkali. They are saying calculate the solution of the pH initially, but the concentration of acid is given to me, the volume of acid is given to me. I have to find pH. This is a past paper question, so I do not go into the depth, I will just solve it. So hydrogen ion concentration, the formula is under root Ka and concentration of acid. So concentration of acid is given here. You see the concentration of acid is given here. I will use this concentration. Ka value is given here. So I need calculator. So I am going to put values in calculator 1.8 into 10 to the power minus 4 into 0.10. So Ka is 1.8 into 10 raised to power minus 4. This value is this. So when I solve this, I will be getting 2, 4. This is the concentration of hydrogen ion. I want pH. pH is equals to negative log of hydrogen ion. So I will take the negative log of my answer and I will be getting pH 2.37. So this is the pH of first one. Second one, its pH like after 20 cubic centimeter, which means 0.01 if I am not wrong. So I need to divide 10 by 1000. Yes. So the alkali has been added now. Now I have to find pH. This is a bit challenging question. In your OCR A-level chemistry, you can find an example, worked example, calculating the pH of buffer solution made by partial neutralization. So here we need to recall the concept of partial neutralization. Let me try. How can I make it easy? So the volume of sodium hydroxide, which is an alkali, is 0.01 cubic decimeter. Its concentration is 0.05 mole per cubic decimeter, given in the question. Yes. While can I find moles? Can I find moles? Yes, you know, concentration is equals to moles upon volume. So moles will be equals to concentration into volume. Concentration is 0.05, volume is 0.01. So when I solve this, I will be getting 5 into 10 raised to, let me solve again. One thing is, yes. So 0.01 times 0.05, 5 into 10 raised to power minus 4. This is the number of a mole. And when sodium hydroxide react with methanoic acid, formic acid, I will be getting a salt and water. So guys, can I say if moles of sodium hydroxide is 5 into 10 raised to power minus 4, the mole of this salt should be 5 into 10 raised to power minus 4. Can I say this? Yes, I can say this. So I can say the moles of this salt, I can also write like this, is 5 into 10 raised to power minus 4. Basically, I have to use Henderson equation, and this is Henderson equation. pH is equals to pKa plus log concentration of a salt over acid. So pH is equals to pKa plus log concentration of salt. Salt is HC negative. Acid is HC So I have to find the concentration of salt. I have to find the concentration of acid in buffer. I am struggling for this. So what I did here, we call it first step. Like first step is calculate amount in mole. The first step I can write calculate amount in mole. Calculate amount in mole of salt in buffer solution. And this is done by partial neutralization. I can write this as well. So this is done by partial neutralization. So I can say the moles of the salt is 5 into 10 raised to power minus 4. And guys, I can also say, remember, I can also say the moles of, because this is 1:1, so I can consider moles of formic acid is 5 into 10 raised to power minus 4. So this is the, you can say, used mole of a formic acid. Like this is the mole which has been reacted with sodium hydroxide. So in a step 2, calculate amount in mole of HCOH formic acid in buffer solution. So now I have to find amount of formic acid in buffer solution in moles, and that is moles of a formic acid, original mole, like original moles which I put, original mole of a formic acid which I put in solution minus used mole of formic acid. Used mole means the mole which reacted with sodium hydroxide. So to find out original moles, guys, I need to use this concentration. You see concentration is 0.10, volume is this. So mole is equals to concentrations times volume. Concentration is 0.10, volume is 0.02. So if I multiply 0.10 times 0.02, I will be getting 2 into 10 raised to power minus 3. So guys, this is the mole. You can say this is the original mole of a formic acid, a kind of original mole of formic acid. So original mole of formic acid is 2 into 10 raised to power minus 3. Yes. And the used mole is this 5 into 10 raised to power minus 4. So when I subtract it, it will be 1.5 into 10 raised to power minus 3. So this is the mole of formic acid, which you can say the leftover mole of formic acid, which is in the buffer solution. Now, because I have to find concentration of formic acid, volume is, no, remember, volume of acid is 20 cubic centimeter. Volume of alkali added is 10 cubic centimeters. So total volume is 30 cubic centimeter, which means 0.03 cubic decimeter. I'm gonna use this volume to find concentration. You guys know this formula. Concentration is equals to moles times volume. So mole is mole of a formic acid, the leftover moles of a formic acid is this one. Volume of solution is 0.03. So concentration will be 4.5 times 10 raised to power minus 5 moles per cubic decimeter. This is the concentration of a formic acid. I have to find concentration of salt as well. You guys can see this is the mole of salt. So again, use the same formula. Concentration is equals to moles times volume, mole. Concentration of a what? Concentration of a salt. So mole is 5 into 10 raised to power minus 4. Volume is 0.03. So 5 into 10 raised to power minus 4. Volume is 0.03. So it will be now 1.5 into 10 raised to power minus 5. So guys, this is the, what is this guys? This is concentration of salt. How I find? You can go over this video again and again. If it does not make sense, don't hesitate. Personally contact me. And this is the concentration of salt. pH is equals to pKa. So pKa means like pKa means negative log of Ka. Value of Ka is given here. I'm gonna use this value 1 point negative log of 1.8 into 10 raised to power minus 4 plus log of salt concentration is 1.5 into 10 raised to power minus 5. Acid concentration is 4.5 into 10 raised to power minus 5. So you need to use your machine. Minus log 1.8 into 10 raised to power minus 4 minus 4. A small mistakes in calculation make our question wrong. 1.5, 10 raised to power minus 5, 4.5, 10 raised to power minus 5. So guys, what I am getting is pH is equals to 3.267. So this is the pH. This is, so I have solved this part. I have solved this part. Now what I do, guys, what I do. Previously in part 2, I have chosen 10 cubic centimeter. Now everything remains same. You just need to put 20 cubic centimeter, then you need to put 30 cubic centimeter, then you need to put 50 cubic centimeter. So let's see if I put 20 cubic centimeter. Okay. So basically, what will I change here? Volume of sodium hydroxide I will change here. So I can solve it. I can solve it. So the first step, again, calculate, like the same step we need to repeat. First step is calculate what? Calculate amount, what? Amount in moles of what? Of salt present in buffer solution. And for this, you need to recall neutralization reaction. This is a kind of revision, don't focus here. This react with sodium hydroxide, you will be getting your salt and you will be getting water. Forget about sodium ion. Forget about sodium ion, don't get confused with it. And volume of alkali is now 20 cubic centimeter, which means 0.02 cubic decimeter concentration. Concentration of alkali sodium hydroxide is same 0.05. So I'm gonna use moles. So mole is concentration times volume. Concentration is 0.05, volume is 0.02. I need calculator 0.05 times 0.02. I am getting 1 into 10 raised to power minus 3. This is the mole. So can I say, my friend, can I say, if the mole of alkali is 1 into 10 raised to power minus 3, this should be 1 into 10 raised to power minus 3. This should be 1 into 10 raised to power minus 3. So I can say the mole of salt is also 1 into 10 raised to power minus 3. Comes to second step, calculate. Step number 2, calculate amount in mole of formic acid in buffer solution. in buffer solution. For this, you need to find original mole, and original mole of a formic acid is constant. We have constant in a sense. We have calculated this before, and that comes out to be where I calculated. Yes, here you see here I calculated 2 into 10 raised to power minus 3. So moles of formic acid in the buffer solution is original mole, original mole minus used mole, or you can say the moles reacted. So original mole is 2 into 10 raised to power minus 3. Used mole is 1 into 10 raised to power minus 3. The leftover mole is 1 into 10 raised to power minus 3. Now the volume is 20 cubic centimeter that comes from acid, 20 cubic centimeter that comes from alkali, so 40 cubic centimeter, which means 0.04 cubic decimeter. Now guys, I have the volume of acid. I have to find concentration of acid. Sorry, I have the mole of acid. I have volume. I have to find concentrations. Moles times volume. Mole is 1 into 10 raised to power minus 3. The volume is 0.04. So it 0.04 is, oh, 4 into 10 raised to power minus 5. So this is the concentration. Similarly, the concentration of this is moles times volume. Now the volume is 0 point. So this is a tricky question. I am not saying these are very simple. You need help from the coaching. Really, you really need help. pH is equals to pKa. So log of 1.8 into 10 raised to power minus 4 plus log of salt 4 into 10 raised to power minus 5. 4 into same value, our good luck. That will be 1. So minus log 1.8 into minus 4 plus log same value. So you will be getting pH is 3.74. So this is the pH. Similarly, guys, when you solve this, you have the 5, 6 different values of pH, then you will have to make a curve. If you need any personal coaching lesson, don't hesitate. You can contact me. Have a nice day. I request do share this video with your classmates. Have a nice day. Enjoy.